Okay, that's enough of that. Good grief. You know you love that intro. If that doesn't get you hyped for math, I don't know what will. Alright, here we go. We kind of got right to the J's. Test review. Test number 1. The big one. You got to get a good score on that. You get a good score on that, you're going to have a good semester. You get a bad score on that, you're going to have a bad semester. Alright, I ain't gonna lie to you. You're going to have a bad one if you don't do well on that. So, let's make it a good one, people. Let's get right into it. Let's just get right into the old math right here. You ready? I'm gonna put the lightest background music on. Amazing. Hopefully that's not too loud. I think it's just right. What do you guys think? Perfect. It's perfect. Absolutely perfect. Alright, so anyways, let's start. Now that everyone's like severely disturbed now. Alright, this problem says put the numbers from least to greatest. The way you want to approach that is just use the calculator. You see, the issue is they're not all in the what do you call it, decimal format here. So let's put them in decimal format. You know what I mean? Desmos. Alright, so just go for it. 12 and 1/10. You have to write it like this, unfortunately, in Desmos, so 12.1. I mean, that should be obvious, but, I mean, I put it like this just in case you need it. Negative square root 145. By the way, you'll notice I typed SQRT really fast, and it turned into a square root. But you could click the square root button down here on the menu. So we got negative 12.1 repeating. Maybe do this to help you. I don't really know how else to describe that. And negative 86 sevenths. So here we go. We're going for it. We're going to do these in order. They're very close number-wise. Now here's the deal. You have to make sure you picked the biggest negative thing to go first. So negative 12.285 is actually the most negative thing. So negative 86 sevenths is what that was. Then the next most negative thing I see is negative 12.11111. That was from the 1 repeating. Then negative 145 in the square root there. And then last 12.1, this is the obvious maximum because the rest were all negative. This positive one's got to be, you know, the most. So the way I did this is I converted them all in Desmos to decimals. And I compared the decimals. Just be super careful because like on mine, I wanted the most negative thing to go first. By the way, if you're doing this for the first time, you might notice that it doesn't have a check button like the typical homework assignments. You don't have that option. You can hit submit assignment and like it'll tell you that you're right on the ones you did, and it'll definitely mark everything else wrong. So you could use that to check to make sure you're doing it right. I'm going to make a bold assumption that I am doing it right. I don't know. Alright, let's evaluate. Listen, I don't mind if you do this by hand, but just for safety's sake, you really should just consider putting this on, you know, Desmos here. Now, you will notice Desmos automatically did this with the division bar like that. That's still right. I mean, it's still following the order of operations, and just to show you, I'll tell you, the order is exponents. That's 64, which is 8 squared, divided by 2, which is 32, and then they added 4 at the end to make this 36 answer that Desmos gave me here. So, there you go. Another one. If you want to do one like this with the big fraction bar on Desmos, you need to put it in a parenthesis, like the entire top thing. Then hit the division, and that will make sure that the top is completely all in one place, and then the bottom is separated. And there you go. That's literally it. You could do it by hand too. There's nothing wrong with that. I would get 27 plus 17, which is 44. 2 squared on the bottom, which is 4. 44 divided by 4 is 11. So if you want to do it in parts, that's totally fine. I just did it all at once. Okay, the next problem says label the set. So they want you to fill out this diagram. We have one of these in our notes. We did this back in lesson 1-2. 1-2? Yeah, pretty sure that's right. So you need to separate these boxes first. So in the right box that has nothing else is just irrational numbers. That's it. Oh, does it color it based on where you put it? Oh, it sure does. Okay, this is a rational number, so it goes over here. That means the other box is all rational numbers. Then you have to make sure you go in order here. What is the next step in rational numbers? It's always integers. Now, I don't know if you're going to necessarily get integers. Maybe it'll skip a set or something. But it's integers. And then inside integers are whole numbers. Now they missed one thing here. They could have gone one further and put natural numbers on the inside. But it always goes like this. Rational numbers could be integers, and integers could be whole numbers, and whole numbers could be natural numbers. This problem just opted not to put that, which is totally fine. And then irrational needs to be off on its own. Alright, then it says true or false. No whole numbers are irrational numbers. That is true. If you are in the whole number circle, you can't be in the irrational numbers box. Are all irrational numbers integers? False. All irrational numbers are over here. Integers are over here. They can't overlap at all. Some whole numbers are not integers. That is false. You'll notice the whole number circle is completely within the integers. If you are a whole number, you are definitely an integer. Some integers are not rational numbers. That is false. If you are in an integer circle, you are in the rational numbers box, and therefore you must be a rational number. Evaluate this expression when a equals 3 and c equals 8. This is kind of like, maybe you recall recently we did a lesson on function notation and plugging stuff in. That's kind of what we're doing here. We're just plugging in a couple numbers. So just plug it in as it is. 3c, which equals 8, plus a squared divided by a, which is 3. So I have to apologize for all the parentheses here, but I had to put a parenthesis around this top thing so that it knew to put on top. I could take it off after the fact. I guess that still technically works. So 3c, so 3 times 8, plus a squared, 3 squared, and then a on the bottom, so it gives me 11. If you want to do it in parts, that's fine. 8 squared is... No, 3 times 8 is 24. 3 squared is 9. 24 plus 9 is 33. 33 divided by 3 is 11. So I can confirm that is all correct here. Evaluate the expression when x equals negative 6. So same thing. Negative 6 squared plus 6x plus 5. Oops, I did a little thing that was weird there. Oh, I put x. I'm not very smart. There you go. Just make sure you fill in each x with the number. So I turned the x into a negative 6. 6 times negative 6 plus 5. So there we go. And I got me 5. Now be super careful, people, because you'll notice I always put this stuff in parentheses. This middle one is kind of like a given. I don't know how else you could write it and still be right. But if you don't put a parenthesis around this first one, notice it changes the answer to negative 67 instead of 5. This is wrong. This thinks... Like, let me show you the difference by itself. Negative 6 squared, it thinks is negative 36, and negative 6 squared, like that, is regular 36. The difference is, this isn't squaring the 6 as a negative. It's squaring 6 regular, then making it negative. This is taking negative 6 times negative 6, which is the right thing to do. So please, put parentheses around expressions when you're plugging stuff in to evaluate them. It's just good formatting. Okay, this says simplify. So the way you simplify is you need to distribute and combine like terms, potentially. So first let me open Paint again. Yes, a blast from our past. Paint returns. Alright, so I'm going to write it all in Paint. Oops. I guess I'll undo that, sure. Alright, so we get 2, y minus 3, negative 4y. So you distribute. Oh, my distribution arrows. 2y minus 6 minus 4y. Please, 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 100% make sure you distribute the 2 to each piece. A lot of people I saw were forgetting to do it times both things in the parentheses. It's got to be both. Okay, then we got some like terms. Negative 4y and 2y together make negative 2y. And then the negative 6 didn't have anything to go with, so it's just off on its own. So there we go. I'll put this off on the side. We're definitely going to be using that in a second. So negative 2y minus 6. I will show you this on Desmos. Thank you, Desmos, for being such a weird thing. If you go on Desmos and you type 2x minus 3 minus 4x, and then you type what you think the answer is, the lines should overlap each other. Notice I got the same overlap. That means I wrote something that is equivalent. So you could use that to check your answer. Desmos won't be happy unless you use x or y. If you use y, I think it should be. No, it is definitely unhappy with me for using y. Okay. Okay, so we're going to make sure they're all x's if we do it like that. All right, and there you go. So I can confirm that's good. On to the next. Another one. So let me get the paint out again. Like this. Okay. Delete all that. Hit the brushes. All right. I'm not going to check this one on Desmos. I'm just going to trust myself to be right. I think I am pretty confident I got this. Here, I'll write the distribution bar under. I guess it doesn't matter which way I do it. Negative 3x minus 6. Please, negative 3 times 2 is negative 6. Plus 5x. All right, and when you add the like terms together, 5x minus 3x. Oops, I guess I should write what it equals. I was about to write it together, which you don't have to do. 2x minus 6. And there you go, 2x minus 6. I wonder if you can still hear my music in the background. Oh, it's playing some cool songs in the background, I guess. Alright, I'm going to let him keep going, I guess, as long as it's okay. Hold on, I closed all my stream information now, darn me. Alright, on to the next problem. Oh, simplify that. Okay, so I'm pretty confident you will probably see one like this. You'll notice the first two just had single letters, like my x's on the side here is just x, or on the one before it was just y. However, on this one we got what appears to be y's and z's. 5y minus 4, negative 6z plus 6y plus 6z. So that's a 6. Alright, now be super careful. Negative 5y is its own thing over here. Then there's negative 4. The negative 4 is what's getting distributed. Not 5y, just the negative 4, because that's what's immediately in front of these parentheses. So this negative 5y is still there. Negative 4 times negative 6z is positive 24z, because a negative times a negative is a positive. Then a negative 4 times a positive 6 is a negative 24. Y, because that one had a y. And then 6z that was chilling at the end is down at the end. Okay, now we got some like terms. We got z's and we got y's. I don't think the order matters. Although I guess in alphabetical order it would be y before z. I'm going to do it reverse just to confirm if Alex counts it as right or not. So 24z and 6z is 30z. And negative 5 and negative 24 is negative 29y. I mean, it looks prettier this way, I ain't going to lie, but it's not in alphabetical order. I don't think it matters, honestly. Okay. Another one. This one doesn't have two kinds of letters. It has x, but it does have different terms. It has x squareds, numbers, and regular x's, and those are different from each other, so you got to be very careful about those. Let me just write it down real quick. Alright, just identify the like terms. We've got squareds that have to go with squareds. I'd always do the biggest exponent first, which is 2. So 2 and negative 18 make negative 16. Then we have 6x. Actually, there's nothing to go with that, so I'm just going to write 6x plus 6x right here. Then we have negative 3 and positive 15, which together they make 12. So this is what we're looking at here. Negative 16x squared plus 6x plus 12. You'll notice I keep making the exponent without clicking this little box here. You can make an exponent with the box. You can hit Shift and 6 on a standard keyboard to make an exponent as well. Kind of up to you. Going a little slower on entering there is not really going to save your life or whatever. Alright, another one of these. I mean, it might be hard for you to tell, but if you ever see problems that look like two of the same, like this one and the one that was right before this one, the odds are on the actual test you're not going to see 2 of those. I mean, you're probably going to, oh wait, not probably, 100% probably going to see 1 like that, so please be prepared to answer 1. However, you will not have to answer 2 like this. The goal is hopefully that you can at least answer 1 of those right and prove you know that skill pretty well. 2 of the same thing should be similar enough that it wouldn't have mattered anyways. Okay, like terms, we've got negative 3x squared, positive 17x squared, which makes 14x squared. We got 6x minus 7x, which is negative 1x, although it is better to write negative x. Alex will mark you wrong if you put a 1 there, so do not do that. Do not put 1 on front of your x's. And then negative 9 didn't have any buddies, so it's just that. So it's just combining like terms. We added the x squareds together, and we got 14x squared. We combined the x's, we got negative 1x. But please, again, just write negative x, otherwise you will be marked wrong, very likely. Unless they, like, corrected that. I mean, maybe you'll get away with being right. Choose the property of real numbers that justifies the equation. So, on these ones, you're going to need to refer to your, well, you're going to need to refer to your memory, possibly. Hopefully you've looked your notes over enough to know which property is which. So you'll notice on this first one, they didn't move any numbers around, but they reordered where the parentheses were. That's the associative property, not of addition, but of multiplication. So here we just learned about associative property. You need to make sure you're choosing the right type of operation. So the associative property of multiplication says you can multiply things in a different order without moving them, just regrouping them. The next one over here says 3 times a plus 7 equals 3a plus 3 times 7. Now this one might be a little hard to tell. You'll notice it became 3a and 3 times 7. 3 wasn't near the 7 initially, so how did it get over there with the 7? Well, they must have distributed it. Like, they didn't. You don't normally have a multiply sign here, but the only way to make 3a and 3 times 7 is to do 3 times a, 3 times 7, and that means you did it into the parentheses, so distributive property. 1 times d equals d. That is the multiplicative identity property, which says if you multiply something by 1, you get the same number again. And then last up here we have negative n plus n equals 0. That's the additive inverse property. Now your mileage may vary. You're not going to get the same questions like I got here. You could have got commutative if they moved something around, like on the first one if they moved numbers around, that's commutative. We did not see the additive identity, which means if you add 0, you get the same number again. We did not see, well, we saw commutative and associative of, well, we saw commutative nowhere. We saw associative of multiplication, but be prepared for addition. Multiplication property of 0 says if you multiply by 0, you get 0. I mean, there's a lot of properties. I'm not going to lie to you, and these 4 questions might not, they're not going to represent all of them. You're only going to get 4, and they probably will be different. I'm not thinking any of these are likely to be the same. It could be, though. So you're going to have to refer to your notes, probably. Learn them well, okay? Okay, the next problem says they are doing a problem, and you're supposed to say what they did as they do each step. So this first one, they changed the parentheses around 9 and 6u to 6u and 2u. That's the associative property of addition, because they associated these two together. Then they combined those. That is combining like terms. Now, when we were in class, we were calling it the substitution property, which I think is a better way to call it, but combining like terms is fair enough. They combined 6u and 2u, and that's combining like terms, which is a fair way to answer it as well. And then they reordered it, which is the commutative property of addition, which says if it's written in an order, you can switch the order around, physically moving 8u in front of the 9. That's okay to do. Now again, you're going to get a problem with a variety of stuff, and you got to answer it the way that makes sense, you know? The graph below. Alright, this is the domain and range, so a new problem type. So to find the domain, oh, that's, wait, what? Interesting. It literally will not let me write a bracket. It wants, I have to click this to make it. How lame. Okay, whatever. So the domain is all the x values. You have to look at each point and think of where the x coordinate is. This is at -4, so I'm going to put that in the domain. These are both at -3, so I'm going to put -3. You don't need to write it twice. If there's repeats of the same value, that is actually unnecessary to rewrite twice. It might even mark you wrong if you do. I don't know. Then 4, because this one's over 4. Okay, now the range is vertical. So this is, so we're thinking, I was thinking left to right here. Now I'm thinking bottom to top. So -4. Well, first let me do this. Then -2. Then 0. Please make sure if it's on an axis, it's probably a 0 somewhere. and then 4. I wrote them from least to greatest. That's not necessary. Alex will mark you correct if you don't write them from least to greatest. It's okay. So I'm going to hit continue. Suppose that this is as follows. So same thing, except for instead of getting a graph, they gave me the points as ordered pairs. The domain is still the x values. That we do an x values on the last one. Here we just have to read them off. So I see 9, I see -4, I see 3, and I see 0. Just the first thing from each set is the x values. It's as simple as that. And no, you'll notice I did not write them from least to greatest, but it should still mark me right. Then we have 4, 9, 3, -1. I will mention, if you happen to get a repeat value, you don't need to type it again. Well, if it's in the domain and in the range, you need to type it again. But if you have like 2 ranges that are 3, you wouldn't need to type 3 twice. Mine were all different. I'm just saying that to you because if you type it twice, I don't know, it might be bad for you. So my problem just didn't happen to have that, but yours could. All right, this one wants you to analyze the graph, I guess. So what is the greatest number of orders in a month? I just need to find the highest. That would be April, between 3,300 and 3,400, so 3,350. When did they have the greatest increase? It looks like from March to April has the biggest rise. Boom. There you go. Analyze the graph. What are you going to do? Hey, look, this looks like some homework I did recently. So we're deciding if this is a function or not. So you're deciding if it's a function based on what's the x values. We have r, x, f, and z. Yes, I know it's not numbers, but none of those were repeated. They're all unique. R, x, f, and z are all different. So if that is the case and there's all unique x values, you're totally going to be fine. You're totally going to be fine. Uh-oh, I have to check to make sure my video isn't... Oh, no, okay, never mind. My stream died on my side window here, but it looks like it was just my computer being a doofus and not the stream breaking on me here, which is good news. All right, we have -6, 4, -5, and 1. Those are all different, so it's a function. Again, if we saw any repeats, that would be bad. Like if I saw 4 here, and then the next number was 4, well, actually, okay, that leads me to a good point. If you see a repeat in x value, it's probably not a function. However, you'll notice all these y values are r, so if this said 4r and the next one said 4r, that would actually be okay. But let me use this first as an example. So this says r -9. If this next one said r regular 9, that would be bad. I don't want 2 of the same x values with different y values. Illustrated on these things down here called mapping. So the way that looks on a mapping is you don't want to see multiple arrows coming out of something. So this 8 with 3 arrows coming out, can't do that. 5 with arrows coming out, can't do that. You can't plug in 8 and get out 3 different numbers. Can't plug in -5 and get out 2 different numbers. Not a function. Now this one illustrates the opposite. These are all going to one thing on the right. That's perfectly okay. That's totally fine. You can do that. So this is a function, as long as each thing on the domain only has 1 arrow coming out. Finding if these are functions or not. So vertical line test. Does it cross anywhere twice if you were to draw a vertical line? Here, you would definitely hit twice if you drew a vertical line, so not a function. Here, these dots, some of them are lined up so that you could hit both vertically. Not a function. Sideways V, draw a vertical line, goes through 2. Nope. Parabola, vertically like this. That's fine, actually. You would never be able to hit 2 parts with a vertical line. Now, this one's a little bit odd. You'll notice that some of these look like you could hit 2 of them at the same time. Open circles don't count, so this actually is a function. None of these lines are overlapping otherwise. Then on the bottom here we have 5 different points. None are aligned vertically with each other, so there is no vertical line that would hit them all, so that's a function. We're getting closer to the end. These ones you need to plug in some values, so by paint. Alright, here's Desmos. So I'm going to do what I did on a previous assignment. You can just type in f of x equals -4x minus 3. Okay, don't do that. Like this. And then if you want to find f of 6, you literally write f of 6. And it gives you that. Now you could plug in everything you need. You could plug in 6. -4 times 6 is -24. -24 minus 3 is -27. You can do it all by hand. It's okay, but I just used Desmos to do the operation for me. Then I'll use g of x function. You'll notice I am typing it in its own row first. You have to do that or the system won't know what to do with your next line. It doesn't know how to find g of negative 2 if you've never told it what the g function is. Ta-da! And it says 18. And you could always verify it. Negative 2 squared is 4. 4 times 4 is 16. And then the minus negative 2 actually adds 2, which makes it 18. So it works out. I'm not going to justify it. I'm just going to say that's a way to do it. And then I got one more of these. On the test, you should probably expect to just see one of these, but notice I erased the existing ones. You don't want to write two things that say f of x, or that would be kind of confusing to Desmos. So I do it. There's a graph again. The graph doesn't really matter. You could even just delete the graph, and it'll still do the stuff normally. F of negative 3. 51. Perfect. Yep, and that's true. That's true. I'm not going to go through and like talk about all the steps, but it is what it is. Negative 2x plus 4. Oops, I forgot to put an equal sign. That's kind of important, huh? Okay, and then g of 4 is negative 4. Woo! We did it! And I try to make it quick. I know watching a video for a long time is a little grueling. This is under 30 minutes. Well, I'm going to do a little explanation, then we'll be a little over 30 minutes. Hey, plus a minute of me like rising up to some epic music. It's so dumb. I'm going to regret looking at that later. Whatever. If somebody gets a laugh and shows it to people, I made your day. It's fine. Hey, look, I got 100%. By the way, if you do not get 100% the first time you hit submit, you can hit quick retake, and it'll take you back to stuff you missed only. You do not have to do the whole thing over again, just the ones you missed. Now, luckily, I didn't miss any. What can I say? It's like I know math. But I'm still going to go to report here, and I'm going to quick run down what the problems were, okay, so you know what to expect. Ordering numbers from least to greatest, convert all the decimals and compare. Next problem. Evaluate. Use a calculator. I don't care. What am I going to do? Use a calculator. A slightly more complicated evaluate. Again, calculating your friend. Follow the order of operations, though, otherwise. This, you're definitely going to need to maybe consider looking at notes. This is organizing a diagram comparing which number groups go within which number groups. The only one missing here is natural numbers in the middle. Then some true or false statements about what numbers belong with which groups. This is some good background music right here. I'm raising the volume on it. Here we plugged in some numbers, and it gave us an output. That's it. Plug in the numbers. Use Desmos. That's fine. I'm going to say to use Desmos a lot. I'm so sorry. Plug in the numbers. That's all you're doing here. Just plugging in. I just plugged in negative 6. Okay, here I distributed and combined like terms and got that. You cannot use Desmos actually on that one. You have to really do that by hand. So refer to the video, that part of the video. Same thing on this one right here. Then we had yet another right here, but this one had two kinds of variables. Hey, look, it said 30z minus 29y was correct. It didn't tell me what was. It would have accepted negative 29y plus 30z as well. There's not a special order it needed to be written in on that one. For those of you that are thinking about that part of the video. Another combining like terms, except for this one has higher exponents, like 2. Could go higher. I think 2 is probably what you're going to see. Another one of those with higher exponents. Number 12, we have choosing the correct property of numbers that matches what they're showing you right there. That's a tricky one. You're gonna need to learn some properties of numbers. This one is working through a problem and you choosing the property of numbers that was applicable in each situation. Getting closer to the end. Running through here. Oh, we're over 30 minutes. Oh no. We have to find the domain and range. Domain are the x values of each coordinate, and the range are the y values. Notice negative 3 repeats, so I did not write it twice. Still going. Another domain and range, except for instead of a graph, I was given ordered pairs, so I wrote all the x values for the domain, and I wrote all the y values for the range. I did not write them from least to greatest, and it still gave me points, so that's good news. Here I figured out what was true about the graph, so what was the greatest orders in a month, estimated the point correctly, and then the greatest increase, I'm looking for a big change right there. That kind of wasn't really exactly the style of question I wanted to give you guys, but it's an easy one, so it's fine. Deciding if stuff is a function, when you have ordered pairs, you're looking for repeats of the x things. I didn't have any repeats on my x things, so mine were both functions. And then when you're looking at these things, these mappings, you don't want to see multiple arrows coming out of one. That's not good. So I had not a function and yes a function. It's background music though. Okay, then we decided if these graphs were functions, vertical line test. If it hits twice, no. Hits twice, no. Hits twice, no. Doesn't hit twice. These don't hit twice, and this one doesn't hit twice. Gotta scroll my thing over. Boop, 19. Two more. These two are the same though, so these were just plugging in f of x. So what you can see on my screen presently is what I was doing here. I plugged in, I actually typed in the formula, and then I typed in what I wanted to find. This is from the second problem, but the first problem I did the same strategy. You could plug it in and do it by hand as well. That's totally fine and acceptable. Yes, and here's the one where I have on your screen. So I plugged in the formula, I plugged in what I wanted, spits out the answer, bada bing, bada boom. All right, that was a little bit. I mean, I got it in 30 minutes. Okay, you gotta give me a break. 30 minutes is the best I could do. So hopefully you watch this video and it helps you maybe find the problem you're having trouble with. I can tell you my number 1 should be the same kind of problem as your number 1. Not the same numbers, but close. My number 2, same but close. If you're watching this video and you got to this point, you probably already figured that out. So good on you. Thank you for watching these videos. I hope they're helping you, and I'm sure the ones who are watching these videos are definitely improving their score they would have got otherwise. So I appreciate you, and I'll see you on the next one, okay? Goodbye.